So now that we know all the types of sequences, we have discussed the arithmetic sequences, we have discussed the quadratic sequences, and we have discussed the geometric sequences. Now, if you had a sequence and you wanted to add all the terms in that sequence, we call that a series. So the sum of terms in a sequence is called a series. Let's see what we are talking about. Suppose that you have a sequence 1, 2, and 3. Now, if you add the terms in your sequence 1, 2, 3, which will give you 6, we call that a series. This right here is your series. So a series is just the sum of the terms in a sequence. Now, let's suppose that, let's make it make sense. So we say that if you have your terms T1, T2, T3, the sum of all the terms in your sequence is what you call a series. So we would write it by saying, okay, the sum of a certain number of terms, because we say that our sequences will go all the way up until it reaches n. So if you want to find the sum, what you are going to do is now just take T1 plus T2 plus T3 plus all terms until you reach Tn. And that is what you call a series, the sum of all terms in a sequence. Now, there are two types of series. We can either have a finite series or an infinite series. We will talk about how the different types of sequences that we have discussed, the quadratic series, the arithmetic series, and the geometric series, when we add the terms of the type of sequence that we are dealing with. But let's talk about the two types of series. Now, your terms could either be finite, which is when we know the number of terms in your sequence. So here we have 3 terms, 1, 2, 3. So we would have S3 here. So we would know that our sequence has 3 terms, and that is a finite series. It's when you find a finite number, when you find the sum of a finite number of terms in a sequence. But also you have an infinite series. An infinite series is when you add many terms and you do not know how far your sequence goes. So let's suppose to make an example with these terms. Now let's end them at 25 and just say after this they continue to infinity. So if you want the sum of the first 3 terms, it will give you 1 plus 4 plus 9, right? Which is 14. But the sequence itself has an infinite number of terms. But here we wanted a finite series. We knew the amount of number of terms we wanted to add, which is 3. We only want to add the first 3 terms. Now remember that when I use this Sn, it's talking about the first terms. So if I say S5, it's speaking about the first 5 terms. If I say S15, it's talking about the first 15 terms. So S will always start from term 1. Now, if we were to look for the sum until infinity, this will require all terms T1, T2 plus T3 plus all the terms until wherever this sequence goes, which in this instance we do not know. So once we do not know how far our sequence goes, we are looking for an infinite series. But in that infinite series, we can decide that we want the sum of the first 3 terms, and that is a finite series because we want a finite number of terms. Sometimes you will be given a sequence whereby it is just a finite number of series, but in some cases your sequence will be infinite and you will have to find the sum of the infinite number of terms, the sum of infinite. We will discuss that in a later video. Now let's talk about sigma notation. Now I said that when you're using Sn, you are looking for the first terms. So from term 1, term 2, term 3, term 4 onwards. But with sigma notation, it is denoted with this symbol. This symbol is S. It's S in Greek. So this symbol just means that we are looking for the sum of. So when you read sigma notation, this letter S in Greek, you are basically just saying the sum of. Now, instead of using Sn, sigma notation can tell us about our sequence by using the S sigma to see what type of addition are we doing. Now, on top of this sigma notation, you will have a letter here, M. Now, I want to use this while I'm explaining this so that you know what I'm talking about. Now, this letter M, in this sequence, the letter is the M is 5. Now, this variable M, it will tell you it is the upper bound of our series, meaning that it is the number of terms that we are going to add up to. Now, in this instance here, if I take you back, we added 3 terms, right? Which means that we added up until term 3. Which means that here we will put 3. Here, since it is 5, we will only go up until term 5. So this M is a position of a term in a sequence that we're gonna end up adding, which will be the last number we add. So it will be our upper bound. Let me write upper bound. So our upper boundary is denoted by the letter M. You can put whatever letter you want here, but as long as you know that it is on top of the sigma letter. So now, if we add up to M, where do we start? We start at, let's use I equal to N. Now, this I, it will be the index of our sum. So this will be our N here is our lower bound. So this is where we're gonna start adding from. So if this is 15 and this is 10, that means we're gonna add the terms from term 10 to term 15. You get what I'm saying? So this is our lower boundary and our upper bound, and I denotes the index of our sum. So this is where we'll start adding up from. So unlike Sn here, where I said Sn will always start from term 1. So Sn always starts with T1, but N here can start from wherever. It just has to be lower than our upper bound. So which means we can start and say, oh, let's say here we had 3, which means that the first term we're gonna add, it will be term 3 in this sequence, and we're gonna add it up all until term 5, which means we're just adding term 3, term 4, and term 5. That makes sense, right? So this will be our lower boundary, and this will be our upper boundary. Now, most people like switching them over. I like them this way. So that I don't confuse you with your teacher, let's go and do it that way. So here they'll put M, and here they will put N. So remember that above the sigma notation is the upper boundary, below you have the lower boundary, and here is the index of the sum. Now on this side of our sigma notation, that's where we will put our Tn. Now our Tn, or let's say Ti, because we've used I, so the index here we'll use Ti. So here this is where you put the general formula of your sequence. So if you are given a sequence like this and you are told to write it in sigma notation, you will find the difference or the ratio or the second difference of your sequence. You will work out the general formula, and then you will put the general formula here. For this sequence, our general formula is 2n minus 4, which means it is an arithmetic sequence, a linear series. So we will add terms in this sequence. So this general formula is for the general formula for the sequence that we are adding up. Remember that sigma notation is the sum of. So here we know that, okay, it is the sum of the terms in this sequence presented by the general formula from term m until term n. It makes sense, right? So here we put our general formula. Now, if you want to find out the number of terms in your series, if you are given a sigma notation like this and you want to find the number of terms in your series, so number of terms in your series, not in your sequence, in your series, are presented by the sigma notation here. You will take the n, which is the upper bound, subtract the lower bound, and add up the number 1. Let me just put it here so that we don't lose it. So the upper bound subtract the lower bound plus 1. Now remember when I put a 3 here, we said that if you start from term 3 and you go up to term 5, you will have term 3, term 4, term 5, which is 3 terms. So let's see if it holds here. The upper bound, remember upper bound n is above the sigma notation, so we'll have 5. The lower bound m, it's given here, which is 3 plus 1. So 5 minus 3 is 2 plus 1, it gives us 3. So we have 3 terms in this series. We are adding up 3 terms. So it tells you how many terms in that series that you are adding up. Now let's expand this series and see an example. So for this series, term 1 will be 2. We're using this general formula, right? Now term 1 in this instance is position number 3. So our first term will be term 3, right? Because it says start from 3 here instead of start from 1. So we'll start with 3n minus 4. That's our term 1. Our term 2 then will be 2 into 4 minus 4. That's our term 2. And 2 into 5. That's our term 3. So you know that we start with term 3, then we go term 4 and term 5. Remember, you skip one, you go in order of 1. So you will go from 3, 4, 5, 6. Even if it starts at 9 and goes to 8, you have to go 9, 10, 11, 12 until 30. You do not skip any tag. So here our first term is given by 6 minus 4 is 2. 8 minus 4 is 4. 10 minus 4 is 6. Now remember, it's a series, so when we do this we are talking about sequences, but we must add them because we are talking about series. So it's plus. So when they say expand a sigma notation, this is what you must provide. So this is the terms of this sequence expanded in series that is presented by the sigma notation. But if they say find the sum, then you will say, okay, it is equal to 12. Do you understand? So this is how our sigma notation works. But remember that with Sn over here, to present it with Sn, you must start from term 1. So if I say S8 of this sequence, then you will find from T1, T2, T3, T4, T5, T6, all the way until T8, right? So Sn always starts from term 1, and with the sigma notation, you can then be specific about which terms that you are looking for. So with an infinite series, our sigma notation will just be, will go until infinity from whatever term that we want or for whatever sequence that we want. So our upper bound, if it is an infinite series, then our upper bound will be infinite because we don't know where we are ending up. We just go in, but we can specify from which term we want to start from, our lower bound. Now, let's present this sequence in sigma notation. So to present this sequence in sigma notation, I already know this is a geometry. So remember that to test what type of sequence you are talking about, you will start by maybe finding a difference and checking if the first difference is common. And if it's common, you are dealing with an arithmetic sequence. If the second difference is common, you are dealing with a quadratic sequence. If like this, 3 divided by 1 is 3, 9 divided by 3 is 3, and 27 divided by 9 is 3. It's a geometric sequence. So you know that these are equal to each other and they represent R. Now, in a geometric sequence, remember it's presented by AR n minus 1, right? So our first term is 1. Our ratio, it's 3. I'm going fast here because we've already discussed how to find the general formula of a geometric sequence in other videos. So here you will have n minus 1. So now we put it in sigma notation. It will be our sigma is our upper bound. So we know how many terms we have in this series, right? So we have 1, 2, 3, 4. So our upper bound is 4, and we are adding it up from term 1. Now, what is our general formula that we put in here? The one is not necessary, so it is 3n minus 1. Now remember that 1 minus 0 will give you 1. Okay, so here it doesn't matter if this is not the first term of the sequence, but if our general formula says that this is the first term of the sequence, so it will fit here in our sigma notation. So this will be our sigma notation for this series. Series is the sum of the terms in a sequence. Here I did an example with geometric. We will discuss the arithmetic, the quadratic, and the geometric sequences series in depth in future videos.